Almost 100 years ago, people didn't believe that flying into space would even be possible. Today, that is more than possible, and people have big plans for the future. This is all thanks to the field of aerospace engineering. But before I get to that, I'm going to tell you a little bit about myself. My name is Allie Lyons. I am a member of the Wind Symphony at Frisco High School. I play clarinet in the Wind Symphony, and I'm also in the Frisco High School Marching Band. On top of that, I'm also a member of the National Honor Society, French Club, Literary Criticism, and last but not least, ISM. So the quote I chose this year for ISM was, "The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge," by Stephen Hawking. I chose this quote because a lot of times people think that, oh, I know so much, I'm so smart and talented, I don't need to learn anything else because I know what I need to know. But there's always so much more on top of that you can always learn. Learning is something that never ends, no matter what. And I chose aerospace engineering because I had a passion for astrophysics, engineering, problem solving, creativity, and aerospace engineering is extremely interdisciplinary. It involves multiple fields of engineering and the sciences to create something in the aerospace field. And so for my research, I began with my career outlook assessment. When I went through my career outlook assessment, the first thing I found was there's information about the aerospace industry, but it's not you can't find it in a very accessible way. So I took this information that I found and I turned it into some infographics that you'll see later on in my PowerPoint. But some of the things I found were that the industry is growing. It's not a lot, but there is growth to it. And there have been a lot of aeronautical technological advances within the past 10 years. There's also a lot of educational topics within aerospace industry that have helped students gain a passion in the aerospace industry, whether it be in high school or college. So here are some of the infographics I made. The first one is, what is aerospace industry? People normally think like, oh, that's planes or rockets, but it's more than that. Aerospace engineering is a field of engineering concerned with the design, development, construction, testing, and operation of vehicles operating in Earth's atmosphere and outer space. So it's more than just things flying around. It's about the people who come up with the idea, design them, and actually build them as well. And then the next thing I have, infographic-wise, is what do aerospace engineers do? So there's multiple steps within the process of what it takes to design a fully finished aircraft. It takes a lot of people to direct it and then design it, and then there also has to be a board that assesses it to see if this is a viable proposal and if the company has the tools and the resources to build something like that. And then they begin to develop that. So once they begin developing their product, they have to make sure it meets all standards within that country, and that includes a lot of inspections, and then finally they're able to develop their final creation. And then within aerospace engineering, there's several specialized fields. So aerodynamics has to do with the drag that an aircraft is exposed to during flight. Thermodynamics has to do with the heat or however cold it will be depending on where the aircraft will be. And then celestial mechanics, it has to do with flight patterns. So here on Earth, there are people that deal with the flight patterns of airplanes, but in space it has more to do with orbital velocity around planets to launch them, depending on where the aircraft is going, launch themselves to the next planet. The next thing is flight mechanics, so this is more of like the inner workings of an aircraft. And then propulsion, which is exactly how it sounds. It propels the aircraft to wherever it's going. So this, the most common one in jets is, just normal gasoline fuel. And then guidance and control systems. So this would be mainly used in military aircraft, when they're trying to communicate with each other, but also in commercial aircraft because they're having to communicate with where their location is in relation to other aircraft. And then here are just a few interesting facts about aerospace engineering. I found these interesting because they're like little projects that companies or teams have been working on within the aerospace field. And so the first one I have up there is about engines, specifically about the Liquid Piston Incorporated. And they signed on to an agreement with the Defense Advanced Research Project Agency, and they created a hyper-efficient rotary engine, and it's just like a father and son company that created this, so it's a pretty big deal. And then another one that I actually did some research on is liquid carbon capsules, which were initially invented by researchers at the University of Bristol. And the next one I have is space. So fuel-conscious scientists at the Johnson Space Center have recently tested an electromagnetic propulsion system that could allow space vehicles to travel faster and longer through the vacuum of space. However, this is very theoretical technology, and it requires a lot of power to get it to work. So it's very unlikely that this will come into play in the future. And then the next one I have has something to do with my original work. This one is by CERN, and they've been working with the European Space Radiation Superconducting Shield project to develop a superconducting magnet that can protect astronauts from space radiation. And I'll get to more about that later. So for some of my research, I first had graphene, and I was interested in graphene because you normally don't hear a lot about it, but essentially what graphene is if you take carbon and you break that down into graphite and then break that graphite down even smaller into just being one atom thick, you get graphene. And graphene actually has a lot of great qualities about it. It conducts heat really well. It can be used in wiring, filtration, and even solar energy because it's such a great conductor. The reason why people don't use graphene that much is because it's extremely difficult to produce. And then for more of my research, I have what are called CubeSats. These are basically miniature satellites that colleges or space agencies can send up into space. And you can send them up there to collect any type of data that you want. They're pretty inexpensive compared to average-sized satellites, which take years to build, and it's really a really good learning opportunity for college students because it gives them a feel of incorporating electrical engineering and mechanical engineering and aerospace engineering all together to create their own satellite. For my first interview, I interviewed Anthony Denota, who is the president of Heli One at CHC. It was interesting talking with him because I got to hear about both sides of the industry, what it means to be an aerospace engineer, but also to be on the leadership side of an aerospace company. And he says that sometimes he did wish that he could go back to being an aerospace engineer, but ultimately he likes his position. Then for more of my research, I did, for my next research assessment, I did polymer matrix composites. So these are pretty cool because there are a few different types of them. The first one that I was talking about earlier was self-releasing microcapsules. So basically, when these capsules come into contact with a force that causes them to break, they release a carbon solution that then solidifies when it comes into contact with the air. The next one I have is space-separated healing agents, which is like two bars, and when the outer bar breaks, when the inner bar breaks, it causes a solution to be released and fill the second outer bar to maintain the integrity of the structure. The next one I found was a microvascular network system, which is pretty similar to the phase-separated healing agent, except it runs all throughout the surface of the aircraft. And it actually looks more like blood vessels, and that's actually where the researchers for this project got the idea from. They wanted to create something that mimicked the human body. In this way, the fluid is spread out more through over the surface area of the aircraft, and it actually maintains the integrity better than the other polymer matrix composites. And then the last one I found was temperature activated, which doesn't work as well as the other ones because it only works at a certain temperature, and that means the aircraft has to either get to that heat point or below it for those capsules to activate. So it's not the best one if you're in a situation where the aircraft won't reach certain temperatures. The next thing I researched was creating graphene, because I read about how it wasn't very easy for engineers or scientists to produce. I was curious as to why that was. Well, graphene originally was discovered by a group of scientists, and they took some graphite and some tape, and they put some graphite on tape, and then they put tape on top of that until there was a little bit of graphite on that, and then they did the process again, put tape on that, and then pull it off, and over again. I actually tried it myself, and I only got to 9 before I could barely see it. But they had like their own tools. It's not as complicated as it may seem compared to the next newer alternative solution, and that would be chemical vapor deposition. There's actually a lot of different ways to create graphene using this method. It's a lot better than the older method because you have more surface area, and the one atom layer thickness is more consistent than it is if you just use the original tape method. Oh, and the scientists that actually did use the tape method to discover graphene actually won a Nobel Prize for that, so I thought that was pretty cool. And then I also researched a new type of propulsion method. It hasn't been implemented yet into the aerospace field, but there has been research on it, and this system was actually designed to be able to swim through like the oceans of Europa, which is one of Jupiter's moons. And basically, the water-like solution goes into the, well, I guess I can't really say spacecraft because it's in water, goes into the body of the spacecraft, and then from there it combusts the water to create hydrogen and oxygen, and from there it uses the two gases to then propel the spacecraft through the water. Then my next interview was with Jeffrey DeHoo. He's an industrial engineer at Lockheed Martin Aeronautics, and it was really interesting to go interview with him because he actually had a full presentation prepared for us, which was really cool. I wasn't expecting that, and he gave us a lot of information. Oh, I went there with 2 other kids from ISM, and then after the presentation, we got to ask him questions and then tour the F-35 facility, it was amazing. Like, it was so cool to see something actually being built there right in front of me. Then my third interview was with Shayla Alfal Jimenez. She is a systems analyst at Lockheed Martin, and she actually really loves her job a lot. Unfortunately, she's moving to Maryland, so she won't be at the Lockheed Martin location in Texas anymore, but this was a phone interview. And then the next one was with Jessica Playa. She's an operations engineer at Lockheed Martin. One of the things that she talked about a lot was the age gap between employees at Lockheed Martin. She said that people who had been there for like 20 or 30 years weren't as open to her ideas or the ideas of other employees like her who were pretty fresh out of college. They wanted to stay in their ways and do things the way they've always been doing them when they had ideas to get things done faster. So she said that was frustrating at times. And she also said that her job is very data oriented. She works with a lot of information and analyzing that information that she receives from the projects. And then my next interview was with Gerald Fisher, who's a systems engineer at Rockwell Collins. The main thing that I talked about with Mr. Fisher was the different types of software he works with. he went on and on about, the different programs, which was really interesting. And I actually researched some of them when I was trying to find one to use for my original work. And then I'm going to get to my original work now, which is on a separate presentation. But basically, it's something to protect astronauts from space radiation. I'll get to that in a second.